Now, we are starting a unit that is definitely a separate entity from the rest of Math 30. There will be, no transformations in this unit. Okay? Now, that could be good or that could be bad. I see it as a bad thing because it'll be a month now that you will have done transformations. So then when we start reviewing the finals, okay, and start getting you ready for the diploma. Now, perms and coms, permutation and combinations, this is one of those units that you really have to be very, very careful reading, okay? The way questions can be asked could be one little word different and you would do the entire question differently, okay? And, finding common information that I can always say, yes, we do this when it says this, okay? Because you're going to find some people are going to think this is the easiest unit in the world. And some of us, okay, how do I do it when it's this way? And how do I do it when it's this way? And we're going to get strategies to get to that place, okay? So that's kind of our separation that I find in this unit. But those people that find it really easy, okay, that's just where your strengths are, and that's cool. But doesn't mean that those of us that find these kind of confusing, we will make sure that we find out a way to be able to get you to learn it. Now the first thing is, let's just talk about the title, okay? Now a permutation is a problem in which order matters. And a combination is obviously when order doesn't matter. This will be the question that you will have to ask once we've learned perms and coms. And because when we learn perms, you're only going to be thinking about that. Oh yeah, it's in this unit or this objective, so I'm going to do perms. And coms the same thing. But what about when a question's asked after you know both of them? And you have to decide, like, ooh, is this a perm or is this a com? Yes. Okay. So does order matter when you go to your combination log? Can you put your three numbers in any order? That means order matters. Okay? So those are not combination logs. Okay? They're permutation logs. Okay? So now, if you need someone's combination, you can say, hey, what's your perm? I need to get your calculator. Okay? I'm just saying that's the right lingo. So this whole time, you have been wrong. This whole time. Okay? Now, what's a scenario where order wouldn't matter? Can anyone give me any example of something where order doesn't matter? Well, it does matter if you don't care. Or, I mean, it's a combination if you don't care. But if you do care, there's a permutation. And it's interesting, but sometimes there will be a debate on which is which. And I had a math department meeting a couple months ago, and they made the diploma very, very, very difficult to look at now, even if you do teach the course. It used to be when the diploma got dropped off and you guys were in the gym, I was handed a copy and I would just sit, in the office and I would read it and I would go through it. Now, if you do not teach that semester, you don't even get to look at it. And the only window you're allowed to do it is on a computer with password protection, all this weird stuff, and an administrator in the room. And shuts down as soon as the time goes off for when, right? The student time goes. So anyway, I didn't know the question from last, but we were sort of a department meeting, and there was two camps on how this question, if it was a perm or a com, and it was just like, there's 5 empty seats on an airplane. How many ways can 3 people coming to the airport buy those tickets? Now, one said, well, that's a perm. And the other said, no, that's a com. Because if you just needed to get on the plane, it's a combination. If you're saying, I need to have a window seat, then it's a permutation. If the actual seats mattered, it's a permutation. If you're like, I don't care, I need to get on that plane, it's a combination. Okay? But how you thought about it, I mean, if you have little kids, the order matters. Like, they need the window seat. So if you've had that, if you're thinking that way going into a test, you would answer it that way. So it was a bad question because it wasn't specific. If it was specific to say, and they didn't care what seats, as long as they got on the airplane, just that one line, then it's a combination. Okay? But they didn't. And kind of left it up to interpretation. And one group said, you know what, doesn't matter. Didn't say Johnny needs a window seat and Jane needs the aisle seat. Didn't say that. Yeah, but, sometimes you have to make assumptions, right? So, is there anything that you can just put 5 numbers in randomly or whatever and it opens? Or is there any passwords that doesn't matter how you put them in? What order? It just opens. So, give me a situation in life that something's a combination. He's got one?
Is that ordering at McDonald's?
Yes. Okay, or ordering a pizza. Like if you ordered ham and pineapple and I ordered a pineapple and ham, which I think is disgusting, by the way. Why would anyone put fruit on a pizza, right?
That's what I was like, and then I actually had a pizza, and it was not
Yes, tomatoes are a fruit because it's not pineapple. One time, it was like late at night, and like a bunch of us were all hungry, and sort of like order pizza. So I'm like order a pizza, and people are like ham and pineapple. People are like ground beef and onion. So I ordered ground beef and pineapple. That is the most disgusting common. Like, it's hard to believe. Like, I can eat. If I'm starving, I can obviously eat pineapple, right? But ground beef and pineapple has this weird thing that goes on. It's like, it smells and tastes like vomit, right? It's like, it's weird how disgusting that is. And one time, a friend, like I'd known him for years, so I thought I knew him anyway, and he brings out this like cheese and jam sandwich. I'm like, are you, like, what? Right? Like I grew up with this guy. I never knew he had these secrets going on, right? And he goes, try it. It's awesome. I can't believe it. And he goes, like in England or some country, he throws at me. They eat that all the time. I'm like, I've never heard of a cheese and jam sandwich. Try it. Strawberry jam and cheese. Just try it once. It was like sliced marble, cheddar cheese, and strawberry jam. Try it once, okay? It's not like you're, I don't know, trying something that's going to change your life. Try it, doesn't work. You're probably still going to work. Move on. Life will be the same. But you might sit back and go, I think I found my favorite food, finally, right? What? No, I'm assuming you do, that it will now be replaced. Yes, let us not talk about food. Well, I'm glad I get to eat in like a half hour. I am dying. I am dying. You know when the cheese like drips over the pizza? That is good. That is good. Yeah. Or when cheese is like dripping off the nachos and they glisten. Okay. Let us stop talking about yummy, delicious food and move on. Okay. Now, yes. What we're going to learn today is one of the simplest ways to do these, yet the most effective way to probably take through the whole unit. Okay? Sometimes we learn something first, and then we find out later that here's a better way or maybe more efficient way. Whereas when you do permutations, this is the most effective way and sometimes the only way when they start to become quite complex. Now we're going to move through this slowly, and there are going to be times where like this, I'm not getting this. Well, this is a transition, obviously. This is something that has never really been taught to you. So we're going to try and establish strategies to get through all of these. So at least if you're on a test and you have no idea what's going on, okay, I'll get this done first. I'll deal with the restrictions now, and then I'll go to this. So hopefully everybody can be successful in this unit, and those that are really good at it, you know, they can just, I guess, be faster. Now, today, first thing we're going to be talking about is the fundamental counting principle. Okay? Now, the fundamental counting principle is as similar or as easy to say is that what we do is we want to count the different options or different types of options, and then we're going to multiply them together. So here's an example. Joe is shopping for a car. Okay? Now the dealer says that there's 3 different models. So we have the models right here. Do you see there's 3 of them? Model 1, 2, or 3. And he says that they're also available in 5 different colors. So Model 1 can be 5 different colors. Model 2, and then Model 3. Now if you look, these are permutations because does the order matter? Can I have a, well, I guess this would have been better if this was, you know, red, blue, and yellow exterior, and then these interiors. Does order matter in that case? Yes, because if you switch them, I don't want that car. Right? The exterior has to be this, and the interior has to be one of these. Okay? But this one, the models, and then there are the colors. Do you see that for each model, there are 5 different colors? And since there are 3 models with 5 different colors, there are 15 choices, right? 5, 5, and 5. So you can see that all you have to do is multiply the number of choices together of the first one times the number of choices of the second one times the number of choices of the third one. Now, let's look at this one. A toy manufacturer makes wooden toys in 3 parts. There's part 1, part 2, and part 3. So picture 3 parts of this toy. Now the top may be red, white, blue, or pink. Okay? So let's do a tree diagram. Now these are kind of, you got to plan ahead of time because they're going to be big. So you want to spread out the first one. There's 4 options. We've got red, white, blue, or pink. Yeah, this is part 1. Okay? Now part 2 can be orange, purple, or black. So right now, we can have a red, orange, red, purple, or red, black. We could have a white, orange, white, purple, white, black. Okay, so it's orange, purple, black. Okay, and then part 3, which is the bottom, could be yellow or green. So each one of these is going to have a Y or a G. Okay, so you can see these are a lot of fun. But could be something they just give you on the diploma. They are very good at making sure that throughout the diploma they tackle probably all those little things that maybe the teacher just kind of doesn't go over. So I would not be drawing these if I had students coming to me going, "Sir, what's a tree diagram? We never did tree diagrams." Even if you've done one tree diagram, you can see they're not that hard, I should say. But you got to do one, okay? Now, you see that we can have, okay, mouse, these dual screens. Okay, so we can have a red, orange, yellow. We can also have a red, orange, green toy. We can have a red, purple, yellow, a red, purple, green, a red, blue, yellow, a red, blue, green. So just in here, we will have, how many? So the fundamental accounting principle says we'll take part 1, which is 4, okay, 4 parts, multiplied by how many options for the next one, which is 3, times how many options for the part 3, which is 2, which gives you, there will be 24 different toys. Okay. Next one. This one's a good one just to do. Let's do example 2 here. If you had a Math 30 quiz, 8 multiple choice questions. Each question has 4 choices. How many different sets of answers are possible? Okay. Now, how many of those would be, well, actually, let's figure out how many different permutations we could have. Does order matter? If you put an A, like say for number 1, are you allowed to put a C just because there's going to be a C somewhere in there? Doesn't 1 specifically have to be A, B, C, or D? So the order you do them, the order you do the question doesn't matter, but you better put question 1 as question 1, question 2 as question 2. Okay? So the order you do the test doesn't matter, but the order I mark it does. I will mark number 1 first, 2, 3. Okay? Now, we have 8 questions. 1, 2, 3, 4, 5, 6, 7, 8. Now, how many choices do I have for the first question? 4. How many choices do I have for the next question? Next question. Okay, so this is 65,536 different tests you could, or scantrons you could hand in. Now how many of these would give you 100%? Just one of them. Now, that's not good. If I go, okay, guys, we got a quiz, 8 questions, you have a 65,536 chance of getting 100. That's a little discouraging, right? So what helps increase your odds? Knowledge. Okay? What's that? Right. If you go, yeah, then it's 2, 2, 2, 2, right? Yes, if someone starts giving you information, okay, you wouldn't believe how much the odds change when they say 4 is B. I know 4 is B for sure. Just that one piece of knowledge changes everything. But it doesn't actually have to be a bad thing to be able to decrease your odds or increase your odds, because if you study, the more you study, the more you take chance away. We were doing probability in one of my classes, and I want to show them how difficult it was to get 100% on an exam. Okay? Like, if I give you, I just want you to look at this bell curve. If I gave you a 20-question test, okay, this would be the average. Okay? That would be the middle of the bell curve. This, right over here, would be your chances of getting 10 out of 20. Now, as you go, more you go to a curve, that's how many people are, what are the odds, right? That's getting 10 out of 20, okay? On a bell curve, getting 20 out of 20 is like way down here. It's so small, okay? And so they're like, well, can we do it? And I'm like, yeah, let's do it. So I gave them all Scantron, right? And I said, just fill in 1 to 20. And they're like a couple people, they're like, what? Like, we don't get to know anything? And I'm like, yeah, you don't get to know anything. And all I did up here is I made an answer key. Well, we're not doing probability, so it's not going to be as... But the most interesting thing that came out is that one student got 10 out of 20, which is very, very rare. And one student got 0 out of 20. Do you see where 0 is on the... No, 0 is as hard as 50%. It's out of 20. This is out of 20, this quiz. See my 20? See, it's 0, 5, 10. Believe it, that's how it works. Because there's 4 choices, you'll get 25% by guessing, most of you. Right? Now, here's the interesting part. My top student in that class got 10 out of 20. And my weakest student in that class got 0 out of 20. He just filled it in randomly, totally by chance. Well, yeah. Maybe we know why one person was the top of the class. We know why maybe the other person was at the bottom. Who knows, right? But I felt bad. I'm like, I don't know if I should give these back. Because we were just going to, like, you know, and they were like, oh, yeah, let's see. I mean, it was fun, right? See what I got, right? Well, geez. Guy's got like 20%, and he gets a 0 on his test that he didn't even know the answers to. But that happened. I'm not even kidding you. Okay. Now, this is a situation where what if we start to know things? How does it change things? And that's what makes these very, very difficult. So as we go through these, you really want to be thinking about it, asking why can't it be this? Okay? Because just like, I mean, I think what would be, if everybody guessed what would be the average, a lot of people would say, well, 50% would be your average. And yet, it's 25% because you have a 1 in 4 chance of getting each question. Okay? If it was a true and false, then it would be 50 because it's 1 out of 2 for every question. Now, here's where we really have to be on our game. And the two things that I've always made us do in this class is, number one, have it very, very quiet during the work time, because these are hard when there's distractions. And number two is have a solution manual out, because these are hard when you're just learning them and you're like taking shots in the dark. But you're looking at what they have and then you're like, okay, I see what they're doing, right? So these are really frustrating without the solution manual, because there's no other way to check them. You can't check them on your calculator. You can't go graph it. There's no backup except for your solution manual. Okay, so they'll help a lot here, especially when you're learning it. You're going to be like, okay, oh yeah, I see why they did that. Okay, so let's start talking about restrictions. Now, just kind of read along with me here. Eric has been assigned a task to determine how many odd 4-digit numbers there are. He's been told that a number such as 5, 2, 6, 7 is a 4-digit number, whereas 0, 2, 6, 7 is classified as a 3-digit number. Now you need to have that knowledge going to the diploma. 756 or 267 is a 3-digit number. Putting a 0 first does not make it a 4-digit number. Okay? Now, if it was a combination lock, I would say zeros full. That's out there that you can use 0. Okay? But if you're just talking a number, like 26 is the same as 026. Now, if you put zeros after, 260 is obviously much different than 26. But putting zeros before does not count as a digit. Okay? So that is something you've always got to know. So this is huge right here. And again, something students get wrong if they have not been showing up to class. Okay? You can't have that argument when you're with yourself in a diploma. That means you weren't ready. You can't be wondering, I wonder if zeros allowed here. Okay? We've had to cross that bridge. You have to have remembered we did it in class. Said, yeah, I remember that discussion. 0 doesn't count. Okay? Now, here's the first thing you should do. So let's not look at what they've done here. Let's go right down to 3, and I'm going to describe. Now, the first thing you always do is do your blanks. It is a 4-digit number. 1, 2, 3, 4. That is key. In fact, that's the hardest step. Because sometimes people don't know what to do with 8 multiple choice. Like, should I do 4 and then do 8, you know? The number of items you're talking about. Next, you always deal with restrictions. Where is there a restriction here? Like, if they say the first number has to be a 9, that's a restriction. What if they told me here that restricts any of these numbers? Why can't I just go 10, 10, 10, 10, 10, 10 times 10 times 10 times 10? I'm done. That's how many, because there's 10 digits, 0 through 9. Remember, 10 is not a digit. It's 0 through 9. Why can't I just go 10 times 10 times 10 times 10? The last number has to be odd. Now, does the last number odd make the entire number odd? Yes. Does the first digit have anything to do with being odd or even? No. And I have people always convinced of that 67 is not odd because of the 6. Okay? Only the last digit dictates that. So, always circle your restriction. There's your restriction. Do that first. We drew the blanks, then you do your restrictions. It has to be 1, 3, 5, 7, or 9. You can even write them in there if you want. So how many choices do I have? 5. Now, then you start from the first number and work and complete the rest. Is there any restrictions on the first number? Yes. So I would actually even circle that and say that it cannot equal 0. So how many choices do I have? 9. Okay. How many choices do I have for the next number? 10. And then 10. So then all you have to do is multiply. 9 times 10 times 10 times 5, which is 4,500. Often I'm just going to give you the answer because the answer is the part that no one's confused about. No one is going to be wondering, going, 9 times 10 times 10 times 5, how did you do that? Okay, well, just put it on a calculator. Okay, so the answer is the easy part. Getting there, setting it up, it's very hard. Okay, now, let's look at this one. Determine how many odd 4-digit numbers which you can have no repeating decimals. No repeating decimals, which is a very, very common way of asking these questions. First of all, I'm going to start like I've always started it. 1, 2, 3, 4. Any restrictions? Has to be odd again. So we got 1, 3, 5, 7, 9. There's 5 choices. Okay? How many choices do I have now? Because this cannot equal 0. How many choices do I have for the first number? I don't have 9. Okay. 3. Yeah. Why don't you have 9? Because you can't use 0. And say if 3 was chosen for the last digit. I can't use 3. Right? Okay, can I write down this number for you? Okay, so if this was, I'm going to just put a 3 there. Now, this cannot equal 3 or 0, correct? So there are 8 choices. That's why it cannot be 9. That's all I'm answering right now. No, it's not. It's got to be odd. You do your restrictions first. That's why. If you do your restrictions first, now I can't have 0 and I can't have the last number. Right, because I can't. 2 are taken. That's all I'm saying. 1 is taken and I'm not allowed to use 0. So here's what I'm trying to tell you. If you had 10 numbers in a bag, okay, and the last one had to be odd, okay, that's the first thing. So if you grabbed like a 5, that's taken out and you put it down. Now how many choices do you have for the first number? 8. Does that make sense? Okay, now I pick it and put it down. How many choices do I have for the second number? I have 8. Because now I can use 0. Okay, just work with me here. How many have I taken out and put it on down here? 2. I've only taken out 2. So I have 8 left. No. This would be 8. And the next one would be 7. Because this one cannot equal the last or 0. This cannot equal the last, cannot equal the first. Yeah, Yeah, I was actually using yeah, right. I was using that 3 as an example of a number. So the answer to this is 2,240. That's the answer. It's very legit. The dates? Well, the first 8, because I only have 2 numbers. You have to picture them in this bag. I've already taken out, say, a 6. Sorry, a 5. Let's just say that. Taking the number 5 out. If I was to reach in and pull out a 0, am I allowed to keep it? No, so you have to put it back. So now I've learned, I can't pick the one that's on the chair already, and I can't pick 0. So there's only 8 for me that I'm allowed to pick. Now if I pick that and say it's a 4, put it down. Do you see I still have 8 things in here for the next number, because it is allowed to be 0. It's allowed to be all of those. Once I pick, there's 3 there, and now I have 7 to pick from. That's where my 7 came in. Okay? Don't worry, it gets a lot harder. Okay? If you are not good at these, the practice will make you a lot better. But you have to run into all the different scenarios. Okay, so here we go. We have car number plates in an African country consist of of a letter, anything but I or O, followed by 3 digits, the first digit which cannot be 0, followed by any 2 letters which are not repeated. How many different car number plates can be provided or produced? Okay? Now this is an easy one. So you can see why you don't want somebody whispering or eating beside you or bugging you as you're going through these. Okay? These are, like, you got to really be concentrating because all those different words, right? Now, the first question I would ask is how many blanks would I do? 6. Okay, the first is a letter. Oops. So this is a letter. Cannot equal I or O. Okay. Then we have followed by 3 digits. 1, 2, 3. The first cannot equal 0. And after that we're followed by 2 letters, and these cannot be. So what have I done? I've put my blanks down, and I've put my restrictions in. To not be repeated. So how many choices for the very first blank? 24. Okay? Cannot equal I or O. Now, for the next 3 blanks, how many choices for the first blank? Okay? Am I allowed to repeat? It says followed by 3 digits. So I can. So then it would be 10 and 10. Now the last two letters, they're independent of the first one. Okay? So how many choices do I have for the first letter? 26. And the second letter? 25. It's independent of the first letter. That's what I just said. Okay? Don't put things in that aren't there. Okay? It says followed by any 2 letters that are not repeated. Well, then there's a problem, because what if I or O are in there? Changes things. So they wouldn't be that complicated at this point. Okay, so now all you do is multiply them together. Like I said, this is the easy part. Multiplying together to get 65,000. Nope, sorry, 14 million. 40,000. Now, again, if you have a question, just calling out or whatever doesn't help. You need to put up your hand and be specific about your question. Okay. Now, sometimes they put pathway questions on, and we'll deal with that in a lot more detail. But the way that we would go, the first question says, well, how many routes are there from Pitland to St. Luke's if we pass through Queensville? Now, if you just watch up here, if you came here, this would be considered as one route. See that? That's one route. This would consist as the second route. And the next one, see, there's 3 ways to get there using the first path and then the next 3. So there's 3 possible ways to get from P to S using the first route, and then 1, 2, 3. So there is, you see, 6 ways. So do you see a faster way we could do that? 2 times 3. So there's 2 ways to get to Queensville, I should say, and then 3 ways to get to St. Luke's. Therefore, there would be 6 ways there. Now, how many ways to go from P to S, but you must pass through R? There's 3 ways here times 1. 3 times 1 equals 3. So the question would be, how many different roads are there from P to S? No, you can never go back. I used to run. Me and this friend of mine used to run with this big Russian, like he used to use in the Russian army, right? And we just we're going from the Kinsman, and we're just starting to go, and my one friend goes, I gotta grab my hat. And this guy goes, you never go back. I'm just like, holy crap, what's he talking about? Just going to get his hat, right? He was like, yeah, that's the first thing he learned when he was in the army. You never go back. I thought that was pretty scary. I was going for a nice run. Now I'm thinking I'm going to get like killed in the woods or something. But anyway, that's what I remember when I do these. You never go back. I need a big Russian guy to come in as a guest speaker just for that. Full military uniform. Okay. So this would equal 9 ways. Because this is an OR. For ands, always multiply. For ORs, you add. Okay? So these are words you have to be looking for. Okay? So if we're talking, we're probably not going to look for those. Okay. Now, this here, let's do these quick. If we have, you can have real numbers that are even the digits, 3, 4, 5, followed by any 4 digits, any 3 digits. So how many digit phone number is that? 6 digits. 1, 2, 3, 4, 5, 6. What's the first digit? 3. So how many chances of getting a 3 are there? 1. Okay, 4 and 5. 1, 1. Okay? Now, how many digits am I allowed for the next one? 10. The next one, 10. Next one, 10. So there are 1,000 different combinations there. But they said, or you can choose this. So or will be plus. The digit 2 followed by one of the digits 1 to 5 followed by any 3 digits. So I have to have the digit 2. How many of those are there? 1. How many would I be allowed for the next digit? How many choices? 5. And the next one? 10, 10, 10. So this would equal, that's 5,000. So together there would be 6,000 phone numbers. Okay. Now, you know how we just did 4-digit odd numbers? We're now going to deal with 4-digit even numbers, which are much more difficult. Okay, now, let's do this one first. How many even 4-digit numbers are there in the whole world? Okay, so 4-digit number, 1, 2, 3, 4. So the question would be, where's my restriction? The last one. What are they allowed to be? 0, 2, 4, 6, 8, right? So how many choices do I have? 5, right? Now how many choices do I have for the first number? 10, 9, or 8? It would be 9, because the only restriction is cannot equal 0. How about for the next digit? Look at the question. How many even 4-digit numbers are there? So 10 and 10. So there are 4,500 different numbers. Now, same question, but non-repeating. Okay? So let's do that down here. Okay? So the same thing. Cannot repeat now. So, what are my choices for the... So let's cross this out. Let's just do it ourselves. 1, 2, 3, 4, 5. 4. Sorry. How many choices do I have for the last digit? 5. Okay. What are they? 0, 2, 4, 6, 8. Now, how many choices do I have for the first digit? 8? Or 7 or 8? Oh, man, that's a tough question. Cannot be 0 or the last number. But let's say, what if the last number is 0? How many choices do I have for the first digit? 9. What if the last digit is 2? How many choices do I have for the first? 8. So this becomes a bit of a problem how to do this. This is going to turn into an OR question. I will do it, first of all, if the last digit is 0, and then I will do it if the last digit is 2, 4, 6, or 8. Okay? So, I have how many choices? So I'm going to do this. That's how we deal with this one. So if it is 0 or if 0 isn't the last. So if it is 0, there will be 1 choice. Now how many choices do I have for the first number? 9. For the next number? 8 and 7, which is 504. Okay, now let's do the next one. I have 2, 4, 6, or 8 I can pick. So there is 4. How many choices for the first number? 8. Because it cannot equal the last or 0. Now, how many choices do I have for the next number? 8. Because now 0's back into the, and then 7, which equals 17 92. So since we add these, 2296. Okay, let's get through the last question here. Now, if you had the letters English, so I want you to picture like little Scrabble letters. So if you have the letters English, and it said, come up with any unique or distinguishable. Distinguishable means that one's different than that one. 4-letter arrangements that can be formed from the word English. They didn't ask for words, right? So GLSH would be considered one of them because it's just a 4-letter arrangement. Now, if I was doing any letter could be in this, can be in any position. So 1, 2, 3, 4. Okay? So is there any restrictions on this one? No. So this is one showing you how to do it without restrictions, and then we'll do the ones with. You can't repeat. Why? You know, it doesn't say that anywhere, does it? Where? Oh, yeah. Yeah, it is. Like, if I take a letter out and put it here, obviously I can't repeat it. There's only one E. So I couldn't make the word. They're actual Scrabble letters. Okay? And they say that they're... So this here, this line won't be in there when it comes to the diploma. Like if they say there are 4 Scrabble letters in a, you know, in a hat or in a bag or something, then you've got to be able to understand, well, that... So how many choices do I have for the first? I have 7 because there's 7 letters. Okay, now see, if I put a G down, how many choices do I have for the next letter? 6, 5, and 4. Okay, so that is 840 if you multiply them. Okay, let's do B. The first letter must be E. So how many choices do I have? 1. Okay, how many choices for the next one? 6, 5, and 4. And that works out to be 120. Do you see how drastically the chances go down if someone gives you just a little piece of information? People wouldn't like intuitively think that it would go down. It goes down to a quarter of the difficulty if you just give me the first letter, right? You wouldn't think that. You only gave me 1 out of the 4. Why does it go down to such a low number? Because that gets rid of the 7 choices right from the beginning. Now, the first and last letters must be vowels. So we're now dealing with this has to be a vowel and this has to be a vowel. So do your restrictions first. How many choices do I have for the first letter? 2. How many choices do I have for the last letter? 1. See how it makes it easier if you do those first. Now, how many letters do I have for the second letter? 5 and 4. Okay? And that would be 40. Now, this one's fun. The word must contain a G. That means G can be on any blank. So if I make the first one 1, okay, that means G is only here. Okay. So is this the way we would do this one? Can we do it as an or? Because we could do or G is here. Oops. Or G is here, or G is here. Okay? So with the ors, we will add them together because the first one adds to 120 equals 120 equals 120 equals 120. So we would just add those together to get 480. Now, the learning of these doesn't stop here. As you're doing the homework and looking at the solution manual, you will be learning from that as well. But you need to, for tomorrow's quiz, can you come up with strategies to do these? Can you come up with strategies by the end of the homework that they're working for you all the time? Okay? That's what you need for these, is a game plan. Because if you're not intuitively good at them, I know there's going to be a handful of people in here, there's nothing that's going to mess them up. I get that every year. Okay? They just are good at this stuff. Their brain is wired that way. You can throw anything at it and they can figure it out. Okay? But most of us mortal people, we got to have strategies. We need a game plan. I do my blanks, circle my restrictions, do them first, then finish off with filling in the rest. So 1 to 18 and omit 15. Okay, they do go quite fast because you're not doing a lot of work for them. Okay, you're just doing your blanks and then filling stuff in.